Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, we will learn how to expand binomial expansions of these two types. This is the way to expand binomial expansions of this type. Copy one here. Then put plus sign. Then write NC1. Make a bracket for the second term. And put the second term here. The second term of the expansion is B. And this number is the power of the second term. Now write NC2, and this number is the power of this second term. I mean, these two numbers are always same. Similarly, you can find the fourth term, which should be NC3. B to the power 3, and so on. And for the last term, write NCN, second term to the power this number. Because when we get both numbers same, that means this is the last term. So this is the way to expand binomial expansion of this type, where the first term is 1 and we have positive sign between the terms. Now let's understand how to expand binomial expansion of this type. So this is very similar to this expansion. This one is similar to this one. We just have this sign difference. So here we have negative sign, here we have positive sign. When we have positive sign here, then all signs are same, like all signs are positive. But when we have negative sign here, then we will copy this result here with alternate signs. First sign is positive, then negative. Just copy this result here, and the signs should be alternate. Plus, minus, plus, minus, plus, minus. So 1 minus NC1 B1, then we have plus sign NC2 B power 2, then negative sign NC3 B cube, and so on. And this is the last term. So this is the way to expand binomial expansions of this type. So we have discussed these two results. So use these two theorems when the first term of the given expansion is 1. For example, in this question, we can use this theorem, 1 minus b whole power n, because the first term of this expansion is 1 and we have negative sign here. And the question is obtain the first 3 terms in the expansion. Well, one last thing regarding this theorem or these theorems. This is the first term, this is the second term, this is the third term, and so on. And this is the last term. So we need first 3 terms in this expansion. So according to binomial theorem, this binomial theorem, we can easily expand this. I'm expanding this here. 1 minus 2x whole power 9. So 1, then put negative sign, n is 9, 9c1, second term is 2x power 1. Then put plus sign, nc2, 2x to the power 2. That's it. just need to simplify this. So 9C1, use your calculator to find the value of 9C1. When you will use your calculator will give you 9. 9C1 is 9. So 9 times 2 makes 18. Your calculator will give you 36. 9C2 is 36. And this is 4 after the square. So 36 times 4 makes 144. And x square. Make sure you give this power to both the terms. So this is the way to expand expansions of this type. And one very important thing, while using these two theorems, especially this one, then never take the sign of the second term. Take the second term positive. Take it without its sign. The sign of the second term is negative, but you have to just take plus b or just b here. I've mentioned this rule here. Never take the negative signs of the second term while using the theorem. See, we didn't consider this negative sign here. We just wrote positive 2x here. So always use second term positive. Never consider this sign here while using the theorem. Another example. Find the first three terms in the expansion of. So, with the help of first binomial theorem, this one, we can easily expand or easily find the first three terms of this expansion. So 1, because of plus sign, all signs must be positive. 5C1, second term is ax, power 1. This number is here. Then 5C2, ax power 2. That's it. We have to find just three terms. So this is the first term, this is the second term, and this is the third term. We just need to simplify this. 5C1 is 5, ax. 5C2 is 10, a square, x square. That's it. Another example, when the first term is 1. Now this is the question. Find the first three terms in the expansion in ascending powers of x. Ascending means small to big. So 1 minus 2x whole power 5. So we will use the second result of binomial theorem. So 1, because of this negative sign, the signs of the expansion must be alternate. So 1 minus 5C1, 2x. Take positive 2x here. So 5C2, 2x to the power 2. That's it. We need the first three terms. This is the first term, this is the second term, and this is the third term. Now simplify these results. 5C1 is 5, and 5 times 2 makes 10. 5C2 is 10, and 10 times 4 makes 40. 40x square. So this is the answer of the first part. Second part, given that the coefficient of x square in this expansion is 12, this means we have 12x square. The coefficient of x square is 12 means 12x square. This is the coefficient of x square. You can write 12 in this way to understand this. In this expansion, if you observe this expansion, then you will see that this expansion and this expansion both are same. So we will use the result of first part here to solve this part. We need the value of constant. So part 2, first copy the question, 1 plus ax plus 2x square. Times 1 minus 2x whole power 5. So we need to use the answer of the part 1 here. And the answer of part 1 is 1 minus 10x plus 40x square. Now, given that the coefficient of x square, so we need to multiply those terms which will give us x square. So we just need to multiply selected terms. We don't need to multiply both the expansions completely. We don't need to expand this completely. It will waste our time. So just multiply those terms which will give you the coefficients of x square, the terms of x square, the terms in x square. So when you will multiply 2x square with this, you will get x square. What if you will multiply 2x square with this? You will get x cube, which is not required. So just multiply 2x square with 1. Now you have to decide to which term you should multiply ax, to this or this or this. Well, when you will multiply ax with this, you will get x, which is not required. When you will multiply ax with this, you will get cube, x cube, which is not required. So you should multiply ax with this term to get the term in x square. And you should multiply 1 with this to make the calculations fast. So when we will multiply this 1 with this, we will get 40x square. When we will multiply ax with minus 10x, we will get minus 10ax square. So 2x square when we will multiply these two. Now we need to equate this result with the given result, 12x square. This was given. Now we just need to equate coefficients. So while equating coefficients, don't cancel x square. Do the calculations like this. So we compared the coefficients of x square on both sides. When you will solve this, you will get the value of a. When we will bring this 2 here, it will be 14. So 14 minus 40 means negative 26 divided by 10. So that should be 2.6 negative. You can check the calculations yourself. You can find the value of a yourself. So this is the way to solve questions of these types. I will understand binomial theorem of these two expansions in my next lecture, inshallah.